we're starting on pairs of lines and angles, and we've already covered some of these. We've dealt with vertical angles and supplementary angles and complementary angles and linear pairs and those. So those are all going to be just a little review, but we're still using those. But what we're going to deal with more, parallel lines, dealing with parallel lines. We've talked about perpendicular lines. Remember, that's the upside down T, and they always form right angles, but also parallel lines. Parallel lines are coplanar lines. Remember, that means lines that are on the same plane. So they have to be on the same plane that never intersect. So two lines that are on the same plane that never intersect. This is the symbol for parallel, just like we had this symbol down here for perpendicular. This is the symbol for parallel. So if it says something like line AB, and then it's got that symbol, and line CD, that's red. Line AB is parallel to line CD. Remember, perpendicular. Perpendicular just means they're lines that intersect and they form four right angles there. The ones that are sort of different, and I can't really show you on this video, but the ones that are sort of different to each other are skew lines. So if you have parallel lines, they got to be on the same plane. Perpendicular lines are lines that intersect each other. So those are two kinds of lines. And then skew lines are lines that aren't coplanar, they're non-coplanar, but they never ever intersect. So if I'm looking at a rectangular prism here, skew lines would be a line like this line right here on that front edge of the rectangular prism, and this line here. They're never going to intersect each other, but they can't be considered parallel to each other. All right, so they're not parallel, but they're never going to intersect. We don't deal with skew lines near as much as we deal with the other two because they're just not as useful, but you need to be able to pick them out. The first postulate here, and we're going to cover several postulates. Through a point not on a line, there's exactly one line parallel to the given line. So if we have this line H, remember we could name this line H if you're using that lowercase letter and that letter is out there on the end instead of naming it with two letters. There's only one line in our world that would go through some point not on that line, so point A there, that is parallel to that line. And that would be that line right there. That's the only line in our world that's parallel to that line. These arrows tell you, those are the symbols for parallel when you're looking at something in the picture. So when you're looking at something in the picture, they'll put extra arrows somehow on the lines, and that tells you that they're parallel. To a point not on the line, this is another postulate. There's exactly one line that's perpendicular to the given line. So again, we got line H here. There's only one line that goes through point A in our world that is going to form right angles with line H. And that would be that line. Remember that little box means perpendicular? Oops, sorry. So there's only one line in our world that could be this line right here that's perpendicular to that. And remember, this, not only is that a right angle, but this is a right angle, so it's 90 degrees. This angle is 90 degrees. This angle is 90 degrees. All four of them end up being right angles there. All right, the special angles that we're going to talk about, these two lines, the two green lines here, line A and line B, are not parallel to each other, but they still form these special angles that we're going to deal with when we're talking about parallel lines. So we have these two coplanar lines, these two green lines are coplanar lines. They're on the same plane. Then we have this red line that intersects them both, and this is very, very important. It's called a transversal. So the transversal is a line that intersects both the other two lines. Notice when that happens, there's 8 angles formed. Some of these angles we already know, like angle 1 and angle 3 are vertical angles. And we already know some things like angle 5 is supplementary to angle 6, because together they form a linear pair, together they form a line. So we already know a whole bunch of stuff about these angles. What we're going to learn today is if these two lines, A and B, the two coplanar lines, are parallel to each other, then there's other special angles. There's angles that have special relationships formed. But we have two coplanar lines, and this line is a transversal. Corresponding angles, the first special pair of angles we're going to talk about. On the notes, because I messed up the notes, there's 2 angle 1s. On all of them, this is going to be angle 4 right here. So make sure you change it. Corresponding angles. If I take, ignore that stray line going up through there. If I take the 2 coplanar lines and I smash them together, so if I smash them together, not fold them, just smash them, corresponding angles are the angles that lay on top of each other. So the special, the pairs of corresponding angles that we have here, angle 1 and angle 5. So if I take this line and shove it down on top of this line, just smash it down, angle 1 would lay right on top of angle 5. Again, not folding it, just smashing them together. The other corresponding angles, angle 2 and angle 6, angle 3 and angle 8, and angle 4 and angle 7. So there's 4 pairs of corresponding angles. Now right now, without these lines being parallel to each other, those angles aren't anything special, but when we get to the parallel lines, then they will be special to each other. And we'll talk about that. But for corresponding angles, you smash the 2 lines together and they come down. The other thing with corresponding angles, if I trace 2 corresponding angles, let's erase all this. If I pick angle 1 and angle 5, so if I trace angle 1, I trace angle 5, notice you can sort of see the together, they sort of form an F. So they sort of form an F. That's corresponding angles. If you trace the 2 angles, angle 1, angle 5, they form an F together. Corresponding angles. Next special pair, alternate interior. And these first 2 are probably the 2 most important ones, the ones that we use the most. Alternate interior angles are exactly what it sounds like. If you're looking at this picture and you have your 2 coplanar lines, and here in a few minutes they're going to be parallel to each other, the interior part, so if we're dealing with interior angles, those are the ones on the insides of the line. So that would be angle 3, angle 4, angle 5, and angle 6. Alternate means they sort of go opposite sides of each other. So the alternate interior angles here, I'm going to erase all this. The alternate interior angles here are angle 4 and angle 6, and angle 3 and angle 5. Those are the pairs of alternate interior angles. with alternate interior angles, and this is probably key for a lot of what we're going to do as the year goes along. If you can see this now, you'll understand it all the way through the year, and it's easy. If I trace angle 4, so that's angle 4, and I trace angle 6, notice they form a Z. So they form a Z, or if the picture was turned the other way, so that the parallel lines were running up and down instead of sideways, you might consider it sort of like an N. But those are alternate interior. They form a Z together, so anytime I'm making that Z, those are alternate interior angles. Next special pair, alternate exterior angles. If these in here were interior, then the ones that are exterior are the ones on the outside. So it'd be 1 and 2 out here, 7 and 8. Alternate exterior, opposite corners of each other. So the exterior angles that are sort of on opposite corners would be 1 and 8. And then you can probably guess the other pair, 2 and 7. So angle 1 and angle 8, alternate exterior, angle 2 and angle 7, alternate exterior angles. Those probably get used the least of any of them, any of the 4 pairs that we're going to talk about, but you still need to know them. Alternate exterior angles. They alternate, so they're on like opposite sides, and they're both exterior angles. Exterior on the outside of the 2 coplanar or parallel lines. The last special pair, consecutive interior angles. Consecutive interior angles, exactly what the name sounds like. Sometimes I call them same side interior angles. Means they're interior, so they're both on the inside of the 2 coplanar lines, but they're on the same side, or they're right next to each other. I usually call them roommates, because they're the only 2 angles that when you look at a picture like this, they're the only 2 angles that are in the same area as each other, without a line between them. There's no wall, no line between them, so they're roommates. They're in that same room. So you can probably guess, again, the interior angles, they gotta be interior angles, so we're picking from those 4. The pairs that are roommates with each other are 4 and 5, and then 3 and 6. Consecutive interior angles, or same side interior angles. Now we still have the vertical angles and the supplementary angles, sorry. So remember, we still have vertical angles, like angle 1 has to be congruent to angle 3 because they're vertical angles. Angle 5 has to be congruent to angle 8 because they're vertical angles. So on, so on, so on. There's 4 different pairs of them there. I'm not going to list them all. You can figure them out. And then the supplementary angles, the ones that make a linear pair together, you could have like angle 5 is supplementary to angle 6, and angle 5 is also supplementary to angle 7. So these 2 together add up to 180. These 2 together add up to 180. And there's many of those pairs there also. So you still have those, don't forget about them. Now what we're going to cover. I'll give you a second to make sure you get this copied down, but notice as you're writing each one of these down, and as we read these, they're all read sort of the same way. They all sort of say the same things. The very first part here says if line, or if you have parallel lines. So you have to start off knowing the two lines that you're dealing with, the two coplanar lines, are parallel to each other. You have to start off with that. Give you a second to fill in everything there. Notice all four of these theorems deal with the special pairs of angles that we just talked about. So the first one, and again, these numbers mean absolutely nothing. They just correspond to numbers in this certain book, but just know that each of these is a theorem, so we know it's something that is a mathematical rule. So the first one says if two lines are parallel, then the corresponding angles must be congruent. So remember, with corresponding angles, they're the ones that we smash the lines together, and they sort of form an F when you smash those two lines together. So those angles have to be congruent, and we'll talk about them on the next few slides. Try to show them a little bit. The second one, again, all these start with if you have parallel lines. So if parallel lines, then alternate interior angles must be congruent. The alternate interior angles, those are the ones that form like a Z or an N. When you trace both of them, they have to be congruent to each other. Next one, alternate exterior angles. And notice that these two are out of position because I wanted all the congruent ones to go together. But if you have parallel lines, then alternate exterior angles must also be congruent. So these first three, the special pairs of angles, are all congruent to each other if the lines are parallel. And then the last one, this is sort of the oddball out of the bunch. The consecutive interior angles, the roommates, they're not congruent to each other, but they're supplementary. So that's why it's sort of different than the others. So the first three, corresponding angles, alternate interior angles, alternate exterior angles. If the lines are parallel, then they have to be congruent. The last one, if the lines are parallel, consecutive interior angles got to add up to 180 degrees. They got to be supplementary to each other. This is everything that we're covering today. This is the main idea of all of it. So if we're looking at this, we can, if these two lines are parallel, which they tell us with these extra arrows right here, so line A and line B are parallel to each other, the two green lines are parallel to each other, then we can pick out certain things. Let's look at like angle 1. We know angle 1 is congruent to angle 3 because they're vertical angles. Alright, so we already know that, but we could also say that angle 1 is congruent to angle 8 because they're alternate, and I'm going to abbreviate a lot of these, exterior angles. If we look at angle 4, we know angle 4 is congruent to angle 2 because they're vertical angles. But we also know that angle 4 is congruent to angle 6. Notice how they form that Z? Because they are alternate interior angles. Now we also know that angle 4 is congruent to angle 7, because if we take the two green lines and smash them together, they are corresponding angles. So just looking at this, I'm just going to name a bunch of pairs of angles. Angle 3 and angle 8 are also corresponding angles. Angle 5 and angle 1 are corresponding angles. Angle 2 and angle 6 are corresponding angles. Angle 3 and angle 6, these two are the roommates, so they're consecutive interior angles, or same side interior angles. So they have to be supplementary to each other. Angle 4 and angle 5 have to be supplementary to each other for the same reason. Angle 6 and angle 2 are corresponding angles. Angle 8 and angle 3 are corresponding angles. Angle 3 and angle 5 are alternate interior angles. If you trace them, they form sort of that Z. So there's all kinds of different things there. Different ways that we can come up with the same answers about certain angles are congruent, certain angles are supplementary. But that only works if these first two lines are parallel to each other. The next one, in a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. So all this is saying is, if we have this first line, line N, and then we have another line, line H, and these two are coplanar, so they're in the same plane, and these two lines are parallel to each other. That's what these arrows tell us, that they're parallel. And then we have a transversal, line T, and we know one of them, line T and line N, are perpendicular, so they form a right angle. Then what has to be true is not only do all four of these angles have to be right angles, but all four of these angles down here have to be right angles. That's all this theorem says. On this example, it says find all the angles. So if we're looking at this and they tell us that this angle is 112 degrees, first thing you might look at, you might say, well, I know angle 5 is 112 degrees because those are vertical angles. Using some of the rules that we covered today, we know angle 5 and angle 3, if I trace those two, they form that Z, are alternate interior angles. So angle 3 also has to be 112 degrees because these two lines are parallel to each other. Angle 5 and angle 1, if we smash the two parallel lines together, they're going to lay on top of each other, so they have to be congruent because they're corresponding angles. So angle 1 has to be 112. We know that angle 5 and angle 4 are the roommates, so they have to be supplementary to each other. So we can just take 180 minus 112, and angle 4 has to be 68 degrees. Well, if angle 4 is 68 degrees, its alternate interior, an alternate interior pair with angle 6, so angle 6 has to be 68. 6 and 7 are vertical angles, so that has to be 68. Angle 7 and angle 2 are alternate exterior angles, so they have to be the same, and that's 68 degrees. And now I found them in certain ways, trying to use all those new rules that we came up with. There's many, many different ways that you could find all those angles, but that's what they all should end up, no matter which way you get to the answers. Next example here. we're looking at this, and this angle that they tell us, the 115 and the x plus 5, they're not really any special pair to each other, but we know that this angle and angle 7 are vertical angles, so that's 115. And then we know that this angle is 115 because they're alternate x2 and 7 are alternate exterior angles. And then these two angles, you could say they have to add up to 180, so x plus 5, plus 115 has to equal 180. That's x plus 120 equals 180. If you subtract 120 on both sides, you end up with x equals 60. So we know x is 60, so we found x. They want us to find all the other angles. Well, if x is 60, then this angle is 65 degrees. That means angle 3 is 65 degrees. Angle 3 and angle 5 are alternate interior angles, so it has to be 65 degrees. Angle 2 and angle 4 are vertical angles, so that's 115. And then down here, we could say angle 3 and angle 6 are corresponding angles. If we smash the two lines together, they're going to lay on top of each other, so it has to be 65. So we found x and we found all the angles. Many, many different ways. The ways I did it, you don't have to necessarily find each angle the way I found each angle. But the answers should come out the same. When you're looking at a picture like this, you got to be careful because you're going to end up messing stuff up. So when we look at this, and it looks like I forgot to put a letter on here or something, so we'll call that line there, line C. This time we got our two parallel lines, that's the two green lines. And then we have two transversals, a red one and a blue one. Well, if I pick the blue one first, this is angle 11, this is angle 12, this is angle 14, this is angle 13, this is angle 10, but here you got to be careful with this angle and this angle. This is angle 5 over here. These two angles are 6 and 7. That angle's 6 and 7 together, and then the bottom part's 8 and 9 together. So you got to be careful when you're looking at this. They tell us angle 10 is 60 degrees, so let's stick that in there. That's 60 degrees right there. Then we can find all these other angles. So if we look at that, angle 10 and angle 11 are alternate exterior angles, so angle 11's got to be 60. And then you can find all these others. 13 is 60. 13 and 14 have to add up to 180, so 14 has to be 120. 12 has to be 120. If 10 is 60, then 5 over here is vertical to it, so it has to be 60. And you'll notice 13 and 5 are alternate interior angles, so they both have to be 60. Now here's where you got to be careful because we can't really find these two angles. We can find the angles, but they're not really the same as the angles in the picture. So we separate off that first picture, and you got to separate these off, otherwise you're going to end up confusing yourself on these problems, some of them. If we separate off the two parallel lines and use the D, the red line, as a transversal, now we got angle 1, angle 2, angle 4 is here, angle 3 is there. And again, the same idea down here at the bottom. This is angle 8 and this is angle 7, but these two angles are two angles over there in the big picture put together. So you got to be careful with that. They tell us angle 7 is 50 degrees, so I'm going to write that in there, that's 50. Well, if angle 7 is 50, then we know angle 8 over here is 50. And if angle 7 is 50, angle 2 and angle 7 are corresponding angles. So angle 2 has to be 50. Well, that tells us angle 4 is 50. Angle 3 and angle 4 are supplementary, so angle 3 has to be 130. Angle 1 then has to be 130. Now, once we have all that, again, we couldn't find these two angles because they're not really in our original picture over here. But if we look at this, angle 5, 6, and 7 have to all add up to 180. Well, 60 plus 50 is 110. We subtract that from 180, and we get angle 6 here has to be 70 degrees. Angle 6 and angle 9 are vertical angles, so angle 9 also has to be 70. But if you don't separate the things off this way, you end up getting confused about some of the angles, and it doesn't take that long to separate them off and to figure it out that way. A crook problem. This problem's called a crook problem because the transversal here is crooked. So we can't really use all of our rules that we have on with a picture like this. Even though these two lines are parallel, we don't have a normal transversal. But what we can do here is right through this crook, right through that point right there, we can draw in another line. And we had that theorem that said through this point there's only one line in our world that we can draw in there that's going to be parallel to this top line, and there's only one line that's going to be parallel to the bottom line. So we can say that that's parallel to that. And then if we look at it on top, we have these two lines, the two parallel lines, the one we drew and the one that they gave us. This angle's 29 degrees. Well, it's an alternate interior angle with this angle. So this angle right here has to be 29 degrees. Now, that's not our whole angle. When we're trying to find the measure of angle 1, that's not our whole angle, but it gets a start of what that angle is. If we look at the bottom and use this as our transversal, and they tell us this angle is 26 degrees, well, these two are alternate interiors, so that has to be 26 degrees. And then to find the measure of angle 1, all we do is add the 29 and the 26 in that case. We get, carry the 1, 55 degrees. So angle 1 is 55 degrees. That's a crook problem. Nothing really hard about it. It's just you have to know that rule that says, hey, we can draw in this line and there's only one line in the world that's going to be parallel to either of the other two lines that goes through that certain point right there. All right, just looking at this, we're just going to name some parallel. If we have this three-dimensional shape, you got to be able to pick out parallel lines, perpendicular lines, and remember that BZ here, even though it's a segment, we could make it a line if we want it to be a line. So we're going to pick out some parallel. So like line BZ, the one I just had, is going to end up being parallel to line LA. So these two are parallel. Line BZ is also parallel to line RE. And I'm not going to name all these. You can go through and name a whole bunch of them there if you want. Line BZ is also parallel to line ST. So be able to pick out all those parallel lines. Those aren't the only ones. We could have said ZA is parallel to BL. ZA is also parallel to RS. And ZA is parallel to line ET. So we could have said all those different ones. Perpendicular. Remember, perpendicular, they come together, form a right angle. Hopefully, if our rectangular prism here, in the corners, it should be right angles. So we could say like line BL is perpendicular to line AL. We could also say that line BL is perpendicular, so this line is perpendicular to line LS. And there's other perpendicular lines. We could look at this line ET is perpendicular to line EZ, and so on, so on, so on. So we could pick out all those perpendicular lines in that picture. There's all kinds of them. And then the last one, the one that most people seem to have the most trouble with, skew lines. Those are going to be, they're not perpendicular to each other because they're never going to intersect, but they're also not parallel to each other. So if we pick one of the lines, let's pick line ST. We want a line that's not parallel to it, so it can't be like AL or BZ or RE, but it's never going to intersect it. So one that I see here, line AZ. Those two are never going to intersect, but they're not parallel to each other. And then ST is also skew. Line ST is also skew to, if we look at this, we could say it's skewed to line BR. So skew, you just got to be able to pick them out. Sort of hard to see sometimes, but just be able to pick them out. We don't deal with skew as much as we deal with parallel and perpendicular. Classify each pair of angles here, angle 4 and angle 5. If we look at angle 4 and angle 5, those are alternate, and I'm just going to use the abbreviations here, alternate interior angles. Angle 3 and angle 7, corresponding angles. And you can abbreviate a lot of these. Angle 3 and angle 5 are consecutive interior angles. Angle 1 and angle 8, angle 1, angle 8, alternate exterior angles. So just be able to classify those. Now in this case, these two lines, they didn't tell us they were parallel, so we can't say anything special about those angles other than there are those special pairs. We can't say that they're congruent or supplementary. Angle 1 and angle 8 in the picture are corresponding angles. And some of these you might have to maybe take your hand and cover up part of it, part of the picture or something. Take your finger and cover up part of it so you can look at it with only the two parallel lines and the one sorry, I drew it the wrong way. The two parallel lines and the one transversal. So you have angle 1 there and angle 8 there. Angle 3 and angle 6, alternate exterior angles. I'm not sure why I have two blanks on some of these. Angle 6 and angle 7, consecutive interior angles. Same idea here. If angle 1 is 72 degrees, we want to find all these other angles. Maybe just sort of cover up part of the picture so that you're not looking at everything. Hopefully the railroad tracks here are parallel. But we can look at this and we can find that angle 72. Angle 3 and angle 7 are corresponding angles, so that's 72. Angle 1 and angle 5 are corresponding angles, so that's 72. Angle 3 and angle 2 are supplementary angles. They form a linear pair, so that has to be 108. Angle 4 then is 108. Angle 4 and angle 6 are alternate interior angles, so that's 108. and angle 8 is 108. Then we can do the same thing, going to the other angles, cover up part of the picture, and look at 9, 10, 11, and 12 over here, and like cover up this part of the picture. So we know that angle 8 and angle 10 are alternate interior angles, so that has to be 108. Angle 5 and angle 11 are alternate interior, so that's 72, sorry. Angle 9, 72, and angle 12 is 108. Angle 3 is 62 degrees. Angle 1 has to be 62 because they're vertical angles. Angle 2, these are alternate interior angles, so that has to be 62 degrees. And angle 2 and 4 are vertical angles, so angle 4 has to be 62 degrees. On this one, angle 3 is 4x plus 7. Ignore that. Angle 6 is 5x minus 13. Those are alternate interior angles, so they have to be congruent to each other. So 5x minus 13 has to equal 4x plus 7. Subtract 4x on both sides. End up with x minus 13 equals 7. Add 13. X equals 20. Once we know x is 20, then we can just plug in and find each one. So if I plug in 20 right there, 5 times 20 is 100, minus 13, 100 minus 13 is 87. So angle 6 is 87, and then we can find all the rest of these. That's 87. Angle 2 has to be 87. Those are alternate exterior angles. Angle 3 has to be 87 degrees. Then to find the others, we subtract 87 from 180. Get 3, borrow there, have to borrow again, that's 93, so angle 8 is 93, 93 degrees, angle 5 is 93, angle 4 is 93, angle 1 is 93. You can find all those angles. The assignment's page 211, it's right there. Make sure you do it.